Sheikh Naim. So today we are going to see a brief about computational fluid dynamics. Everyone knows nowadays computational fluid dynamics is a trending topic for mechanical aerospace engineers. So we'll see a brief about computational fluid dynamics. So computational fluid dynamics is have a short form which is called CFD. So most of the people known by this term which is called CFD. So CFD is nothing but, or computational fluid dynamics is nothing but, it is the science which deals with the fluid flow phenomenon by considering the mass, momentum, and energy conservative laws. So with the help of mass, momentum, and energy governing or conservative laws, we will be going to solve the problems which are related to fluid flow. Okay, then. So there are vast applications of the CFD. Already said aerodynamics and aerospace people are using this CFD for analyzing their aeroplanes, rocket, ramjet engine. They are vigorously using this CFD CFD or computational fluid dynamics in their uh, areas. And not only in aerodynamics and aerospace, weather simulation, and their biological engineers also using this computational fluid dynamics tools for analyzing their blood pressure. And sometimes before going to any surgery, they will do simulation with the help of computational fluid dynamics. That means when they try to do any surgery, if any nerve will be going to cut during that surgery, they will see what is the fluid flow phenomenon of the blood that will be analyzed with the help of computational fluid dynamics software. Then we are using in heat transfer phenomenon, and everyone knows the computational fluid dynamics is mostly used in the IC engines, that is internal combustion engine analysis. Okay, that. So CFD has mainly three steps. One is pre-processing. Second one we have a uh, processing, or that is also called as solution processing. Third one we have a post-processing. If you see in pre-processing, in CFD, what you are doing in pre-processing. So if you have a geometry, okay, I have a object I was designed in the CFD software. Then so this is called geometry preparation. Then after modeling or drafting your geometry, later you need to convert it into smaller number of elements. So this method is called meshing. Then after doing meshing, then we need to know what type of material it is, whether it is structural steel, mild steel, or copper. Those material properties also we need to impose it onto our geometry. That is material properties assigning. Then later we need to apply the boundary condition. That means we need to supply inlet conditions for our geometry. That is, it may be velocity, it may be pressure, and it may be temperature. Whatever inlet conditions are there, we need to supply to our geometry, and also we need to define the outlet condition. Okay, in some cases, outlet conditions are not required. For some of the applications, outlet conditions are already predefined, and we need to see what is the behavior occur inside our geometry. Okay? That coming to solution processing. So in pre-processing, we done everything. Just in solution processing, suppose we have a calculator, and we have one equation x plus b y equal to suppose 5. This is the equation. So we have already a coefficient b value, and we have suppose y value. We need to obtain x value. Simply we can do in the calculator. In similar way, in solution processing, we already have all the governing equation, that is mass, momentum, and energy equation, and we also have a boundary condition, inlet and outlet boundary condition. All are given to a computer where it is computing. That is called solution processing. And after solution processing, we have a final step is called post processing. In post processing, just we are going to visualize the result. See, we have a geometry. After applying inlet and outlet condition, so there is a fluid behavior is changing. Suppose this is the fluid which is flowing in this way. That means fluid is not flowing in a straight pattern, it is flowing in a zigzag pattern. That means we try to identify this zigzag pattern of the fluid flow is nothing but turbulent behavior. Suppose we have in another problem, if the fluid is flowing in a straight path from inlet to outlet, this phenomena is nothing but laminar. These things will be visualized in the post processing step. Okay? So how many steps are there in CFD analysis? There are mainly three steps are there. First one, pre-processing. Second one, we have a solution processing or processing step. Third one, we have a post-processing step. Okay. So it is about brief about computational fluid dynamics. In upcoming lectures, we are going to see some of the physical problem in the ANSYS fluid flow fluent. Okay. Thank you.